All right, this is an FRQ from the 2012 FRQs, the AB test number 4. So they give you the function f of x is the square root of 25 minus x squared on the interval, and they're asking you to go ahead and find f prime of x. And so I'll go ahead and do that. I'm going to start off just by saying that f of x is 25 minus x squared to the 1/2. I'm doing that so that I can use the chain rule as I find the derivative. And so once I have that, sorry, make it so you can see better. That means that f prime of x is 1/2. I'm going to keep the inside the same, drop the exponent by 1, and then multiply by the derivative of the inside. So multiply by negative 2x. And technically you should be able to leave it like that because you technically don't have to simplify, but I'm going to go ahead and actually simplify it. So there is my derivative. And that's all they wanted, so part A is done. Part B says write an equation for the line tangent to the graph. And so for a tangent line, I need to have the point and I need to have the slope at that point. So I know that I'm plugging negative 3 in for x. Sorry, that was my phone. Plugging in negative 3, I've got the square root of 25 minus negative 3 squared. So I've got 25 minus 9, and that's going to give me, sorry, I'm trying to turn my phone on silent. I thought I was going to be slick about it. Okay, 25 minus 9, square root of 16, so that's 4. And so the point we're working with is negative 3, 4. And then I already found the derivative, I just have to plug in negative 3. So f prime of negative 3 is negative of negative 3 over 25 minus negative 3 squared is positive 3 over 4. So my tangent line is y minus 4 equals 3/4 times x plus 3. All right, for part C, they give you a piecewise function. They want to know if it's continuous at x equals negative 3, and they want to use the definition of continuity to explain your answer. So definition of continuity, if you guys recall, is 3 different parts. The first part is that you can plug in the number. So we want to make sure that g of negative 3 is defined. And so I'm going to go back up here. If I plug in negative 3 to this piecewise function, I should be using the first piece. So g of negative 3 is actually f of negative 3. And f of negative 3 we already found is 4. So g of negative 3 is defined. The second part of the definition of continuity is that the left-hand limit and the right-hand limit are the same, meaning that the limit exists for that number. So next we're going to say the limit as x approaches negative 3 from the left of g of x. That's what we just figured out. It's 4. The limit as x approaches negative 3 from the right of g of x would be the other part of the piecewise function. And so if I plug negative 3 in here, even though it can't equal negative 3, it's still going to find the right-hand limit. So negative 3 plus 7 is also 4. So the limit as x approaches negative 3 of g of x exists. And then the third part of the definition is that the evaluation of the function with the number plugged in and the limit of the function at that number are equivalent. So the limit and evaluation are the same. Therefore, G is continuous at x equals -3. All right, and then the last part of the problem is to find the value of the integral from 0 to 5 of x times square root 25 minus x squared. So D this is just a U substitution problem, not exactly from Unit 1, but I figured I could go ahead and leave it anyway. So U is going to be 25 minus x squared. Du is -2x dx. I can see an x in the problem, but not a -2 in front of it. That was not a dy, that was supposed to be a du. Now, if you want to do the integration in terms of in terms of u, and then at the end of the problem convert it back into x, you could. I think it's good for you guys to practice plugging these values in and rewriting them in terms of u and just leaving the problem in u at the end, because that is a skill that we ran into on multiple choice problems as being important. So 25 minus 0 squared is 25. If I plug in 5, I get 25 minus 25 equals 0. So if I'm doing this problem in terms of u, went ahead and put the -1/2 in the front. Instead of going from 0 to 5, I'm going from 25 to 0. So 0 became 25, 5 became 0. And then I've got square root of u du. Okay. So that's u to the 1/2. So if I add 1 to the exponent, I get u to the 3/2 divided by 3/2. It's being evaluated from 25 to 0, a little bit backwards there. Okay, so I've got -1/2 times 2/3 u to the 3/2. So -1/3 times 0 to the 3/2 minus -1/3 times 25 to the 3/2. And you can leave it there. Since this is a practice problem, I'm going to go ahead and keep going. Those are all gone. Minus minus makes a plus. The square root of 25 is 5, so times 5 to the 3rd. 5 to the 3rd is 125, so 125 thirds is the answer there.